Hi everyone, this is YML and today we are going to talk about several ReLU variants that in some way or another try to improve this activation function. The first function that we are going to talk about is Leaky ReLU or LReLU for short. And the way it modifies the ReLU function is that on the negative side, instead of having only a value of 0, we have a value proportional to x to the input value, but this value is much smaller in comparison with what we have on the positive side. And this is reflected here because we multiply the x value with a small constant like 0.01. And this fact is also reflected here on this graph because here we have like this line that is slightly below 0. So this here like reflects the values on the negative side on the Leaky ReLU. And we modified the ReLU function in this way because we wanted to have some kind of signal even when we have negative values. The second function that I would like to talk about is Parametric ReLU or PReLU. This one is quite similar to Leaky ReLU because on the negative side we also have x multiplied by some kind of value a, but in comparison with Leaky ReLU, this variable here a is a learnable parameter. So in some way, we let the model decide what kind of activation function we want on the negative side and don't force it on some kind of constant value that we considered useful. And the way PReLU works is also displayed here on this graph with multiple lines, but not because PReLU has multiple lines, but because I wanted to reflect the fact that on the negative side, this function can have like multiple way of controlling the values there. It's not a fixed like line as we had in the previous case in Leaky ReLU or even in the classical ReLU function. The next ReLU variant that I would like to talk about is the Gaussian Error Linear Unit or GELU for short. This one has been quite successful and it has been applied in models like BERTs. And it is defined as the input value multiplied with what's known as the cumulative distribution function of the normal distribution here. And we noted it with the symbol phi. And this cumulative distribution function is defined in this equation here, but I won't go into too much details regarding it because there is a lot of resources on the internet regarding this function, and I don't want this video to be too long. And here on the left figure, we have the GELU function, and you can observe that when we have values that are close to 0 and that are negative, we have here this slight bulb here that is due to this cumulative function. And what is interesting about the GELU function is that it allows only the negative values that are close to 0 to transmit any kind of signals. So only the negative values, as you can see in our graph, between -2 and 0 have some kind of negative signal, and the values that are less than -2 have a signal that is like very close to 0 here. The next ReLU variant that I would like to talk about is called Sigmoid Linear Unit or SILU for short, and this one is defined at x multiplied by sigmoid of x. And this is a very interesting multiplication and an interesting ReLU derivation, and we'll see shortly why. To better illustrate why, let's just draw here by hand how the sigmoid function looks like. So it starts from here, it goes a little bit up, here a little bit up. Here we have 0.5, the value of 0, and it goes a little bit higher and higher and higher, and then it converges to 1. So here we have 1 and here we have 0. And what we get when we multiply the input x with the sigmoid function is that for values that are very negative, we get a value of 0 here. And for values that are very high and on the positive side, we get a value equal to x here. And with values that are around 0, we get the variable x that is multiplied with some kind of coefficient that is between 0 and 1. And this happens around here between -4 and 4. And you might observe that this activation function is very similar to the GELU activation function because it allows negative signal only when the x value is very close to 0 here. And for values that are very negative, the signal is equal to 0. The next ReLU variant that I'm going to talk about is called Softplus. And this is defined as the natural logarithm of 1 plus e to the power of x. And just as a little remark, if we didn't have this one here, then the function would be simply natural logarithm of e of x, and it will be equal to x. So the graph would look something like that. But because we have this one here, then our function is in some way bounded by the logarithm of 1, which is equal to 0. So consequently, our graph would look something like that here with green. So for values that are very negative, e to the power of x will tend to 0, and we'll have something like that in our graph. And as the value of x increases, then also the value of e to the power of x increases, and it starts to go slowly here. You can observe that in comparison with GELU or SILU, the graph this time is above the ReLU and not beyond ReLU for negative values that are close to 0. And it grows and grows, and then you can see that it converges in some way to xy, because for values that are very high, e to the power of x becomes a very high value and outshines this little one here in comparison. And when we apply the logarithm here, then e to the power of x becomes simply x. The final ReLU activation function that I would like to talk about is called Exponential Linear Unit, or ELU for short. And this one is similar to the ReLU. It has again two branches, one for the positive side and one for the negative side. And obviously on the negative side, it's a little bit different. So here you have A, which is a constant. So it's not something like a learnable parameter. And here we have e to the power of x minus 1. And what happens here is that as x tends to minus infinity, this one tends to 0. So in some way, everything here tends to minus 1. And this minus 1 here is multiplied to a, and basically everything tends to minus a as we go to minus infinity. And we can also observe this behavior here in this graph. You can see that as we go to minus infinity, this value on the negative side tends to minus a. And in our case, I said this a equal to, so a was equal to 0.1. But I've seen the authors of the original paper using an a equals to 1. So yeah, these are the ReLU variants that we have talked about in this video. I believe there are more out there in the literature, but these are the ones that I encountered most frequently. Also, you might wonder which one is the best one, and for this question, I don't have a clear answer. All I can say is that there is not a free lunch, and you have to experiment with these functions by yourself and see which one is better for your specific case. As always, I would like to thank you for watching this video, and if you enjoyed it, please leave a like, and until next time, I hope that you have a great time and see you soon.